Yes, in this combination, if you show this molecule, follow the three conditions. One is cyclic, another one is conjugation, third one is planar, fourth one is 4n plus 2 pi electrons rules. Yes, it is cyclic. One is condition. Conjugation. Yes, this is involved double bond. Here you get positive charge. If shifted to here, here you get positive. Like this, it is conjugation. Yes, all carbon atoms are in planar, sp2 only. 4n plus 2, 1, 2 pi electron. Yes, it follows this rule. This is called also aromatic. This is 4n pi electron. This is anti-aromatic. These are the some of the examples of the aromatic character of the molecule. Next, one more concept, another concept. Next, in this case, annuline. What is annuline? Next, to discuss about the annulines. What is annuline? How we do it? This is X-annuline. What is the definition of annuline? This is also cyclic conjugated aromatic compound without charge called annuline. Cyclic conjugated compound without charge, that is called annuline. If you take for example 2 annuline, 4 annuline, 2 annuline is not existed, only 4 annuline, 6 annuline, 8 annuline, 10 annuline, like this. What is 4 annuline? This is the cyclic system conjugated without charge. If it is, this is also engineering also called as 8 annuline. If you take this one, this is 8 annuline. You take 10 annuline, this is 10 annuline. If you take 4 annuline, it is aromatic or anti-aromatic? Yes, one is cyclic, condition is satisfied. 2 is conjugation, yes, it is planar. Fourth one is 4n plus 2 pi electron. This rule is not satisfied, only 4n pi electrons rule is satisfied. That's why this is anti-aromatic. You know this is aromatic. If you take this annuline, this is not planar, this is tube-like structure. How it is this tube-like structure? Like this tube-like structure. This is not planar. Not planar means non-aromatic. Non-aromatic. If you take tenolin, this hydrogen and these two hydrogens are above and below. One is plain above, another is, that's why this is non-planar. This is also not aromatic. If you take 2 alanine, 14 alanine, 12 alanine, after that these are the, we should not show aromatic character. 12 alanine is anti-aromatic. This is aromatic. Like this, we can classify the molecule into aromatic and non-aromatic. Next, like this. What is annuline? First of all, it is the cyclic conjugated compound, cyclic conjugated aromatic compound without charge. Then those compounds are called annuline. It is denoted X annuline. If it is 4, this is 4 annuline, 6 annuline, 8 annuline, 10 annuline. After that, all are in planar only. If you take consider 8 annuline, 10 annuline, these two are non-planar. This is tube-like structure existed. This is one. These hydrogens are crossing each other. That's why this is what is above and below the plane. The remaining all are planar only. This is the annulines. Next, I will give some of the example. Next, I will give some of the example. Comment on aromaticity. Comment on aromaticity. I will give some of the example. One is, this is boron. Next, like this. You take like this. Take if you find out the it is aromatic or non-aromatic. How you find out this? One is this one, 2, 3 and 4. Please identify it is aromatic or non-aromatic or anti-aromatic. First you take this one, B, boron atom. First condition is cyclic. Cyclic. Second condition is conjugation. Third one is must be planar. Fourth one is 4n plus 2 pi equals 2. If it is aromatic, 4n plus 2. If it is non-aromatic, 4n pi equals. First it is conjugation. Yes, this is boron having vacant p orbital. That's why it is in the conjugation. All are in sp2. Cyclic, it is conditions for conjugation. Planar, because 1, 2, 3. 3 are sp2 hybridized. All are sp2. How many pi electrons are there? Only 4 pi electrons are there. See here, 4n pi electrons. That's why this is anti-aromatic. Boron not having electrons, lone pair electrons. It is vacant orbital. That's why it is anti-aromatic. If you take this one, nitrogen also having lone pair, but double bonded nitrogen does not, lone pair does not involve in this conjugation. Only this oxygen lone pair involved in the conjugation. First condition is cyclic, yes. Second condition is conjugation, yes. Third one is planar. This is sp2 hybridized because this lone pair involved in the conjugation. This is also after lone pair. This is also sp2 hybridized. Double, single, lone pair. Same all are in sp2 hybridized. Yes, it is planar. This lone pair involved in the conjugation. That's why this is 6 pi electrons. Means it follows the 4n plus 2 pi electrons who cancel. That's why it is aromatic. If you take boron, this is vacant orbital. Same like that. So it will involve in the conjugation. 6 pi electrons. All are sp2. That's why this is aromatic character. This nitrogen. This is having double bonded nitrogen. Lone pair never involved in the conjugation. Only this nitrogen lone pair contain lone pair involved in the conjugation. All are in sp2 hybridized. That's why it is aromatic. 4n plus 2 pi electrons. Yes, this is the condition. Aromatic, and also this is also aromatic. That is 4n pi electron. That is anti-aromatic. Next, this one is aromatic. This is the some of the examples of molecules. Next I will discuss about the inorganic benzene. Same like this, can so many the molecule. Next, inorganic benzene. Boron, nitrogen, boron, nitrogen, nitrogen, boron, nitrogen. Double bond, single, double bond, single, nitrogen. How many boron having how many bonds? Nitrogen having how many bonds? This is also boron is having all are in hydrogen, hydrogen, hydrogen. This is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. Yes, this is B negative charge and then positive charge. B negative charge and positive charge. B negative charge and positive charge. Because 1, 2, 3, 4, 1, 3. Lone pair and donated. That's why this is inorganic benzene. Yes, in this case if you see, first condition is cyclic. Yes, it is cyclic. Second condition is conjugation. Yes, all are in conjugation only, because like this, all are in conjugation. Third one is planar. Yes, it is planar, because what is the boron? Say 1, 2, 3 sigma bonds. Yes, it is planar. This is coordination, coordinate bond. This nitrogen, yes, 1, 2, 3. Yes, sp2 hybridization. All are in planar and sp2 hybrid cyclic and follow the 4n+2 5 electrons rule. Hence, this is called as a aromatic compound. This is the inorganic compound to show the aromatic character of the molecule. Next, one of the most important topic I want to discuss now, to compare the dipole moment. One is, if you take a double bond, in this case we have to compare the dipole moment first. Compare the dipole moment of the molecule. What is the dipole moment? How to get? If you take this one, here with positive charge, O minus is negative charge. Here with positive charge, here also O minus is positive. Then here positive charge, here with O minus charge. To compare the dipole moment of the molecule, dipole moment depends upon the directly proportional to stability of carbocation. Stability of carbocation. Okay, which is more stable, then it is dipole moment is most. This positive charge cyclic, first condition starts. Third one is planar, it is non-planar, that's why it is non-aromatic. It is cyclic, conjugation, planar. This is aromatic. This is anti-aromatic. What is the 1, 2, 3? Which is more? Aromatic is more. Second one, then non-aromatic, then anti-aromatic. Third one. This is the dipole moment of the above molecule series order. To compare the acidic strength of the molecule, same molecule I have given. Third one is hydrogen. If you compare the acidic strength of the, to compare the acidic strength, second one is acidic strength. If you compare acidic strength of the yellow compound, if you want, if you by donating H plus, it will form this, like this. Negative. The acidic strength depends upon the stability of the carbene ion. Carbocation. If you compare the stability of the carbene ion, acidic strength is directly proportional to stability of the carbene ion. If it is more stable carbene ion, then it is more acidic character. This is anti-aromatic, this is aromatic, this is non-aromatic. Which is more stable? This is 1, 2, 3. Please. Third one is more acidic, then compared to 1, then compared to 2. This is the sequence order of the acidic character of the molecule. Next. Next, to compare the reactivity towards silver nitrate. Next, to compare reactivity towards silver nitrate. Take chlorine. If you take this one, then alkyl halide react with silver nitrate will form. What will form? Alkyl plus X minus it will form silver plus it will react with will form silver chloride. Then what is silver chloride is white PPT, silver bromide is pale yellow, silver iodide is dark yellow, pale yellow, dark yellow. The reactivity, how fast it is, how fast that is reactivity with the alkyl halide with silver, it depends upon the stability of the carbocation. If it is form more stable carbocation, then it will fast will react with the silver plus with the X minus. Depends upon this only, this carbocation stability only, then it will form the reactivity of the molecule. If it is more stable, this one, this is more reactive. If you take this one, it is positive charge, which is more reactive, that depends upon the stability of this carbocation. If you take this is non-aromatic, you know, this is aromatic, this is anti-aromatic. First 2, 3. If you compare this one, which one is more reactive? More stable is more reactive. Second one is greater than, first is greater than third. This is the sequence of the reactivity of the molecule with the silver nitrate. Next, I take one more, another same in this concept. One more. Compare reactivity towards acids. Reactivity towards acids. Reactivity towards acids. If you take this one, OH, reactivity towards acids. To take HX, HN, H2SO4, H3PO4, orthophosphoric acid, and H3O plus. If you take any alcohol, if you take OH group, it is having lone pair, if it donates to the H plus ion, then it will forms OH2 plus. Oxygen positive charge is unstable, it immediately loses the water, then it will form carbocation plus water, alkyl cation plus water. This this is more stable. If it is more stable, it will form more stable, then it is called as more reactive. Okay, na? This is more stable. Alcohol or OH, it will release the H plus ions. H plus ion vacant orbital, the oxygen having lone pair, this lone pair donate to the H plus, then it will form H2O plus. Oxygen with positive charge is unstable, it immediately lose the water, then it will form R12 plus and water release. How much is stable? More, if it is more stable, then it is more reactive. That is stability of this alkyl plus ion depends upon the reactivity of this molecule. If you take this one, this is having positive charge. After releasing water, this is also positive charge. After releasing water, this is positive charge. If it is non-aromatic, it is aromatic. This is anti-aromatic. 1, 2, 3. Aromatic is, second one is greater than, first one is greater than third. This is the sequence of the order of the reactivity towards the acids. Next, ring flipping. To compare rotational energy barrier. To compare, next, rotational energy barrier of the molecule. To compare rotational energy barrier. Take for example two molecule. One on this one. Please compare the rotational energy barrier. In this, for this, if you compare rotational energy barrier, here you get positive and a negative. What will happen if you take, if you compare, if it is, this lone pair is break, it will form, if like this, two possibilities are there. If you get what will happen? Here you get minus charge, here you get plus charge. There we will get positive charge and there we will get minus charge. What will happen if you get here positive charge? This is 4n pi x. This is anti-aromatic. This negative charge is involved in the localization. This is aromatic. If you take in this case, two possibilities are. One is like this. When will what will form? Where it is stable. Here you get positive and here you get negative. If it is like this, here you get negative charge, here is positive charge. Which one is more stable? If it is get negative charge, this is also aromatic, this is aromatic. This is anti-aromatic, this is also anti-aromatic. Because this positive charge you get localization, this is also, but this is 4n pi electron, this is also 4n, that is anti-aromatic. This is unstable, this is stable. Okay. Yes. Next the same like this. In this case, two positive are there, no same like this. This is the rotational energy barrier. Means this electrons moves, one is upside, another one is downside. Like this, depends upon the stability of the molecule. We can move the electrons. Okay. So thank you friends. Aromatics we discussed completed.